2.7 is entitled Inverse Functions. Any questions for me? Inverse functions. Okay, let me give you an example. Let's say you have in your pocket an unknown amount of money. X, we don't care. And let's say I give you $10, and 5 minutes later I say, give my $10 back. What happened to your amount of money? It's the same. Nothing happened, right? I can say something else. In the reverse order, give me $10, and then 3 minutes later, I'll give you your money back. So I can add 10, and then immediately subtract, nothing happened. Or I can subtract, but then add, and still nothing happened. This is function composition. So when I apply these two functions in any order, add and subtract, or subtract and add, nothing happens to x. Why? Because these two functions, the second one, the outer function, annuls, if you want, the effect of the first one. It cancels the effect of the first one. Right? Because adding and subtracting are inverse operations. Can you give me two functions in such a way that if we apply this one first and then this one, nothing happens to x, or if we apply this one first and then this one, still nothing happens to x? Can you think of anything? Right. Awesome. So if you multiply by 3, so you have x, you multiply by 3, but then you immediately divide by 3. What happened to x? Nothing. Because multiplication and division by the same number are inverse operations. What about taking square root? And what are the function? X squared. Right. They are inverse operations. So if I apply them in any order, nothing will happen to x. How are these two functions called? Inverse functions. Why? Because f come g of x and g come f of x equal perfect. Plain x. This is the property of inverse functions. Nothing happens to x, which means f and g are, how do we call them? Blah, blah, blah of each other.
Parallel.
Huh, that was good. No. So f and g are of each other. Opposite will mean f of x and negative f of x. I used the word a second ago.
Inverse?
Exactly. So f and g are inverses of each other. In other words, if you apply f first and then you apply g, what happened to x? Nothing. If you apply g first and then immediately f, what happens to x? Because these two functions are inverses of each other. One cancels the effect of the first one. The second one cancels the effect of the first one. Okay, so let's look at one example. We are on page 321. We are given two functions. Let's say problem 7, page 321. Yes, we are given f of x, which is 3 over x minus 4, and we are given g of x, which is 3 over x plus 4. The question is, well, are these two inverses of each other? I don't know. I don't know. By simply looking at them, I don't know whether they are inverses of each other. But I know what I have to determine. And what do I have to determine? What do I have to find?
X.
Careful. Exactly. I have to find this. And I have to find this. And if it happens that they are not the same, if it happens that they both equal x, then what do I say about f and g? They cancel their effect on x. One cancels the other, so they must be inverses of each other. Perfect. That's what we have to do. So let's find f comma g in the hope that the answer is indeed. So f comma g of x. I have to write the definition first. What is the definition of f comma g? Very good. F of g of x. Not to be understood as a product. This is not a product here. I'm not saying you said that. I'm just emphasizing. This is not a product. This is f of g of x. Good. So, of course, I start with the inner function. So this will be f of. Awesome. And now I have to take a break for a second and look at f. What does f say? F says 3 over whatever minus 4. So 3 over
x plus 4.
And then minus 4. What happens here? The 4's go away. The numerator is a fraction. It's 3 over 1. Everything divided by 3 over x. If you remember, 3 is 3 over 1, 5 is 5 over 1, 10 is 10 over 1, okay? How do I divide two fractions? That's why I emphasized it like that, so we can discuss how do I divide these two fractions. Very good. I copy the fraction from the top and use the multiplicative inverse for the bottom. I've seen in your test, you first multiply and then you forget to simplify. That's not a good habit. Always simplify first before you multiply, if you can. So what is the answer? What can we say about f and g? They must be inverses of each other. Okay, we have a few more minutes. Let's find g.
Do we cross multiply there? Or we just multiply it?
So I copy the numerator,
right,
and I multiply by the multiplicative inverse of, so I have 3 divided by 3 is 1. 3 divided by 3 is 1. I simplify first before I multiply. So that's why 1, x, 1, I get x. So now let's also find g comp f. Do you think that this answer will be x? It will be. If f comp g was x, do you think g comp f will be x? Yes, otherwise they will not be inverses of each other. If the first one is x, the second one will be too. So let's say we don't know that. What is the answer for this? What is the first step? Perfect. I start from the inside. So this is g of, very good, 3 over x minus 4. Now I have to take a break a second and look at g. What does g say? G says 3 over whatever you want and outside plus 4. So, can anyone dictate? 3 over? 3 over? This is what I want. This is what I'm evaluating. So that's why I'm looking at G. 3 over whatever and outside plus 4. So 3 over?
No. 3 over,
yes,
3 divided by x.
Exactly, that's the variable.
4.
And then outside plus 4. Very good. Remember, the top is 3 over 1. What do I do? Exactly. So I copy 3 over 1 and multiply by x minus 4 over 3 and outside plus 4. Please get into the habit of simplify first, not distribute, not multiply. Simplify first if you can. 3 divided by 3 is 1. 3 divided by 3 is 1. What is left from the first product? And what is the answer? So let's write the conclusion. Therefore, f and g are inverses of they are inverses of each other. Section 2.7 is not finished.